Welcome. So we're going to answer this question before us. It says, 2 bowls each contain 8 pieces of fruit. In bowl A, there are 5 oranges and 3 apples. In bowl B, there are 1 orange and 7 apples. Find the probability that 2 pieces of fruit chosen at random will both be apples if the first piece of fruit is not replaced before the second piece of fruit is chosen. Okay, so a pretty traditional tree diagram question without replacement here. The first thing we need to consider is that we have bowl A and bowl B. Now there's a 50-50 chance of getting either bowl A or bowl B. We then can either get an apple or an orange, and let's look at bowl A first. For bowl A, there are 5 oranges and 3 apples. So that means there's a 3 on 8 chance of getting an apple. Now what we care about is getting 2 apples out in a row. So the probability of getting another apple here, remember we don't care about oranges, the probability of getting another apple will be 2 on 7. Because remember, we're not dealing with replacement here. So we're doing it without replacement, which means we have 1 less apple and 1 less in total. And then we're going to do the same thing for bowl B here. For bowl B, what's the probability of getting an apple and an apple again? For bowl B, we're told that there are 7 apples. So that means initially there's a 7 on 8 chance of pulling out an apple, and then 6 on 7 chance of pulling out an apple. Therefore, to figure out what the probability of A intersection of 2 apples is going to be 1/2 times 3 on 8 times 2 on 7. So as you can see here, all that I'm doing is to solve this, I'm multiplying across the tree. That's what that is here. And then I'll do the same thing down here. I'll go, well, what's the probability of B intersection of 2 apples? And that's going to be 1/2 times 7 on 8 times, whoopsie daisy, 7 on 8 times 6 on 7. So as you can see, now I'm going like that to get this. Really important is that before you multiply, you always simplify. So here, as you can see, this 2 will cancel with that 2. Anything else here simplify? No, it will not. So that means I'm going to end up with 3 on, what's 8 sevens? 56. And then we do the same thing over here. Now, what can simplify here? Well, this 7 will simplify with that 7. This will simplify with that. So that means once all is said and done here, I'm going to end up with 3 on 8. Yeah, 3 on 8. Perfect. Now that I've got both of these, for me to figure out the probability of 2 apples, I'm simply going to add them together. So I'm going to go 3 on 56 plus 3 on 8. So that means I'm going to times this by 7 and this by 7. I'm going to get 3 on 56 plus 21 on 56, which is 24 on 56. Then you have to ask yourself, can 24 and 56 be simplified? It can be simplified here, and it's going to end up being 3 on 7. It's quite possible that there was a better way to do that just like the simplifying bit there. Like instead of timesing by 7, maybe simplify that 3 on 56 rather, right? Well, 3 on 56 can't be simplified. That might have been the best way to do it. All right, doesn't matter. There we go. So when you can simplify, you must. We continue on. B. For part B, it says, 1 bowl is chosen at random, and from it 2 pieces of fruit are chosen at random without replacement. If both pieces of fruit are apples, find the probability that bowl A was chosen. Now, it's really important that when you read these questions, you really pick up on whether or not there's like conditional probability happening here. And do you notice, just notice the phrasing here. Both pieces of fruit are apples. So that means that's the given part. We know that both are apples. What we're trying to figure out is the probability that bowl A was chosen. So A given 2 apples. So that's the probability of A intersection of 2 apples. The probability of 2 apples. Now, this is where you should be able to look back on what you've done and say, I know the probability of getting 2 apples out is 3 on 7. I also know what the probability of A intersection of 2 apples is 3 on 56. That means I can simply go 3 on 56 times stay, change, flip. So I flip this around. That 3 will cancel with that 3, which means I'm going to be left with 7 on 56. 7 on 56. Make sure you simplify when you can, because that's going to be 1 on 8. And that's going to be my answer. So really important that you can kind of get a sense of how one question leads on to the next, and how you can really utilize what you've done previously to answer questions really quickly. But that's how you answer that question. Hopefully you found this helpful, and I'll see you in the next one.